everyone, and welcome to today's EAStalk webinar organized by the European Aquaculture Society. My name is Anna Viskovic, and I'm the Project and Program Manager at EAS, and I will be your host for this session. We are really glad to have you with us today. Before we begin, a few quick housekeeping points. This webinar is being recorded and will be made available to participants afterwards. We will have a dedicated Q&A session at the end of the presentation. Please use the Q&A function to submit your questions at any time during the presentation. It's now my great pleasure to introduce today's speaker. Our guest is Professor Ruth Pincinato, professor at the University of Stavanger in Norway, where she specialized in aquaculture economics, seafood markets, and the economics of sustainable food systems. Ruth's research focuses on market integration, productivity, efficiency, and the economic impacts of regulation and technological change in fisheries and aquaculture, a rich and increasingly important field as we seek to understand how aquatic food systems can grow and evolve sustainably. Today, Ruth will take us through an economic perspective on a fascinating question: what explains sustained production growth in aquatic food system? She will offer an introduction to key themes from aquaculture economics and management, including economic incentives, institutional frameworks, technological change, and market dynamics, and how these factors have shaped the remarkable expansion of aquaculture over recent decades. In addition, Ruth will give us a brief preview of the Aquaculture Economics and Management Workshop taking place as part of the Aquaculture Europe 2026 in Ljubljana, Slovenia in September this year. So please do stay tuned for that. Ruth, it's wonderful to have you with us. The floor is yours.
Thank you so much, Anna, and thank you really for the opportunity for sharing some thoughts on this topic. I hope, as you said, I will just, it's a brief talk about or sharing my thoughts on this question that we could extend way further, and I hope to do it in Ljubljana in September. What explains sustained production growth in aquatic systems? And I want to, of course, I will provide an economic perspective, as Anna said, on it. And I would like to start by showing this graph here that you have seen it before, probably, that shows the growth in aquatic animal production coming mainly from aquaculture, shifting from fisheries that used to have it's a hunting model to a more controlled production environment that is aquaculture. And basically this sustained production growth can be mainly explained by productivity growth, right? That has been fueled by innovations in fish genetics, feed, fish health, and production technology. So in practice, we are producing more output with the same amount of inputs. And this is really important. While wild fisheries, as we just show, and here in this figure is like in this shaded gray area, have reached its limits. We can see, we see that the demand for seafood has grown a lot and is keep growing, right, as income and populations have increased. We represented that here by this black line in the graph, showing like real world income. So all this demand growth and have been basically supplied by aquaculture. And this is really important because despite this strong increase in demand, real seafood prices have remained relatively stable over time. So in this picture here, we showed by the gray light gray line, and is really important to have stable price not only for producers but also for consumers and food security globally, right? So and for that matter, also environment. If we think that seafood has a relatively lower footprint than other sources of proteins like cattle. So this is really important, particularly also when we are considering FAO estimates on how much production of aquatic animals should increase if we want to keep the current levels of per capita consumption over the next couple of years, or even we should consider higher growth if we consider that some countries have a lower seafood consumption than what is actually recommended, right? But this growth is not uniformly distributed globally, and while you can see some regions like Africa and Latin American countries with 8% growth per year, North America almost nothing. So is quite uniformly distributed globally. And growth in general can happen in different ways. So economists usually use the term margins, different margins that it can grow. And for instance, like can grow through the extensive margin, like adding more locations to fish to grow, more companies. But you can also grow through the intensive margin, where you actually intensify and improve efficiency in existing operations. So many ways to grow. But before we show a bit more on examples within aquaculture, I would like to zoom out a bit. We have seen this growth over the last decades, but it was not always been like that, and we shouldn't take it for granted, right? Like this productivity being like a source of this continuous growth. So I will zoom out a bit and look at the general economic growth that is has shown similar, right, is for the economy as a general, but it can be applied to many industries. And here we see, for instance, the GDP per capita, that is an indicator of, for instance, living standards, and over time for many countries. And you can see that for many centuries, actually, it has been quite low, not grown at all, right? And in fact, Thomas Malthus, an economist that you probably have heard about before, argued back then that even if technology improved, population would grow faster than food supply. So living standards could never rise permanently, like it was like a trap. So as we can see from this graph, actually for centuries that seemed to be true. But it was by the start of the 18th and 19th centuries that we could actually see that this growth have been sustained, right? So I want to share with you a bit more of how he explained why we were not growing. So basically, according to him, there was a trap, right? So we would have increase in productivity, incomes would increase, but they would always, like in a way, fluctuate, right? They wouldn't rise permanently. So, and in a way, the same as we see today, there has been technological improvement, there has been innovations, like if we think about new crops, new techniques, equipment, and by that, if you think that at that time, most of people would actually work land, right? So agriculture would be something quite important. But what his model show is that this technology would improve, and then here, right, and then living with that living standards were relatively low, but the technology would improve. That would lead to actually higher productivity. By average output per farmer would rise, meaning that they would have more resources, more income to spend. and that would also lead to a population increase. And the thing with especially land, right, is that you have a fixed amount of land to farm. So with a population increase and most people actually working on the land, that would mean less land per farmer. So the average output per farmer would again fall as population increase. And then population is larger, but living standards are back to the original level. So that is where the poverty trap keep going, right? And so all the productivity gains that would have from technology and innovations would basically go towards like increasing population and not like improving income. So that was important insight, but somehow we left this poverty trap, right? And how that happened, right? And the economists usually attribute key aspects of the time that when capitalism rose during the 18th century. And the main aspects of it would be related to the institutional aspects of ensuring private property rights, markets, and firms. So that was a turning point, and basically reshaped how production was organized. Right, so production moved away from small family-based activities towards large firms where workers could specialize in narrow tasks. And this specialization would make production more efficient. At the same time, competition among firms would create a lot of incentives to improve and use the better technologies available, most efficient production methods, right? So basically a lot of incentives to innovate, to be in business. And more than that, one thing that actually the Nobel Prize last year's Joe Mokir was his insight, and he got the prize for that, is that during that time it rose like what he called useful knowledge. And by useful knowledge, he means that the combination of two kinds of knowledge. So you have the prescriptive knowledge, that is basically where you have practical instructions, right? You have like what you need to do for things to work, and that is more like the practical aspects, right, of business. But also you have propositional knowledge, that is more like why things work. That is a lot related to scientific method, research, right, and to understanding why things work that way, grounded in science. And when you mix both knowledges, you have useful knowledge, and that is when you have sustained growth, right? It's and you kind of like related that time also to the Enlightenment, right? You need to have these two interactions, like the interaction between these two knowledges to actually keep growth. So the key takeaway from this general economic growth model is that basically institutions that will support this support and foment this innovations and creation of this type of knowledges are very important to keep growth coming, right, like a sustained growth. And it's important to know that this shouldn't be taken for granted, right? Like these institutions should be, we should make sure that they are in place always, right? So I want to move from this back to like our aquaculture context, And I wanted to show some of these insights that I just mentioned we can see throughout the Norwegian salmon aquaculture development, or at least some of them we can apply and see directly over these years. And they actually so they started they have experienced a lot of innovations over time, right? Not only process innovations that are related to how fish are produced, so things like better genetics, advanced feeds, automated feeding systems, disease management, but also product innovations where they have changed what is sold and how consumers perceive it. So, for example, developing value-added products, new packaging, improved freshness through logistics, certifications for sustainability, and all these innovations have increased willingness to pay and expanded global demand for salmon. So these two innovations were quite important for the salmon aquaculture in Norway to develop. And before, like during the 70s, this is how it looked, the production system in Norway. So it's more like an extensive system, relatively low cost, lower productivity, and higher exposed to risk. So more exposed to weather events and disease, more susceptible to that, to the shocks. And this is how it looked like today. Moved towards more intensive systems with greater control over production, for instance, feeding systems, which allows higher productivity, more stable output, also better resource use, right, efficiency, but of course requires higher capital investment and more skilled management. And it is a development, right? We are still like, that is how most of the farms look like in Norway now. But of course, this is like, it has been developing more and more, and innovation are still coming. So a lot of investments on given their current challenges, a lot of investments on different systems where you have even more control over the production. So recirculating aquaculture systems in land-based or even inshore, but more semi-closed systems, or also more exposed offshore systems. All have been alternatives or like being thought as potential alternatives to the current system, or adding, right, to the current system. So it has been a lot of developments there as well. Some of the innovations that has happened a lot over the years regarding, for instance, genetics and nutrition. So survival rate in salmon farming has really gone up. Genetics related to smolts and the fish in the grow out phase with respect to vaccines as well also have helped not only with the survival rate, but also with the growth and better growth, and also shorten the cycle of the production. Feed has had a tremendous improvement as well, that has helped a lot with the conversion rate and so on. The scale, right, increased a lot, and this brought huge productivity gains so lower labor costs per kilo of fish, better fish distribution, and more stable environment conditions. Of course, this has also increased capital intensity and complexity. but it's in a way increase productivity as well. But so this is a general figure of how Norwegian farming has salmon farming has evolved a bit over time, but how we can model like this production growth. So we start by assuming that we are dealing with a competitive market. So in a competitive market, individual firms cannot set the price, right? They cannot tell how much they want to sell the fish for. They basically take the market price as given. So what they can do is to basically minimize cost given how much they want to produce. And this, so basically they also can control how efficient they produce. So then their goal is to produce up to the point where the extra cost of making one more unit, that is basically this part here, that is the marginal cost, is exactly equal to the price they will get from what they are selling. And this is where they maximize profit. So when firms become more productive, they can produce the same amount of output with fewer inputs or lower costs. And lower costs mean also that their marginal cost curve shifts down, and that allows them to make more profit at lower prices. So one of the so this is good for their profits, but also these cost reductions usually in a competitive market are gradually passed on to consumers in the form of lower prices also for the consumers. So and we do see this in many food sectors, including aquaculture. We can basically we do this modeling by modeling production, right? That is a Q would be the output of production, and here in function of like the capital, the labor, the other inputs, and so on. So it's basically a mathematical description of the firm's production technology. And here, when I say technology, this doesn't just mean machines or equipment, it's really knowledge. It includes everything the firms know about how to transform inputs into outputs, so how materials are combined, how processes are organized, right, management, and so on. And if you compare, for instance, two firms using the same amount of inputs, they might have different outputs. So simply because no one uses a better or more efficient technology. So this is important when we are modeling, right, and help us to understand why, like what happens when why firms are different in terms of productivity and so on. So we can better understand these relationships. And here I show like a different way of showing the production function. Basically, you have the output here, and you have the amount of inputs in the x axis. In this case, for instance, labor. And here we have all the under this line. We have all the production possibility that we can have. So. Right, like all the amount of inputs that you can use and how much you can get of output for. But basically the line is what we call the production frontier. That is the maximum of output you can get given the amount of inputs you are using. And if you are under this curve, that means basically that you have some inefficiency in your production. When we are modeling productivity, then what means is that we basically are modeling how this curve shifts up, right? So basically you are able to produce more output by the same amount of input. And this we put in the model as total factor productivity. That includes like innovation, knowledge, and technology that makes all inputs more effective. So this is basically how we model productivity gains and as I said, like what sustained production growth. Here we show the development of salmon farming in Norway. And here is basically like an example of what I said before. So you can see here the production increase of salmon production, right, increase over time in the red line, followed by a decrease in costs with this like orange line here, at least up to the middle of the line here, middle, like around 2005, and followed by also the prices that are sales prices per kilogram in blue follows the actual the costs of per kilogram, right? So it's basically what I mentioned before regarding like how all this is passed through eventually pass gradually through to the consumers. But the interesting as well is that we can see here the different innovations related to the salmon farming. For instance, regarding feed, right? There has been many feed innovations throughout the years. Also in relation to fish health, vaccines and other factors, innovations on that side. Equipments as well have improved a lot, not only like technological improvements for production, but also with respect to other issues like scapees and so on have improved a lot. And finally, government regulation also not only like innovations with this regard, especially like providing incentives for the farmers to innovate and with respect to some challenges that they have, for instance, sea lice outbreaks and diseases. So that has been quite a big problem, and actually is one of the main explanations for the changes that have happened here by the end of this time series here with respect to costs. So these cost changes largely are driven by external factors. For instance, these outbreaks, right? Like they have been dealing with this, and in a way they have treated or trying to address this by treating the fish or by trying to prevent these outbreaks, and this is reflected in their increase in the costs. And also in general, like input prices, right? Feed has been or is in general, right, a dominant input cost, and a lot of the ingredients have increased a lot in price. For instance, like fish oil, right? Like nowadays we not only sourced by salmon or like aquaculture, but also for supplements. So it's a lot of outside the control of farmers. Also, one point in the development of salmon farming is related to the scale gains that they, as I said before, they have scaled up a lot, and this have had a lot reflect a lot their productivity. But lately, it seems that they could have some potential cost savings if they expand production, but these are constrained by regulations. So there has been a lot of work on that, especially from the government side, but still, yeah, we need more innovation on that to come. So I tried so far to provide some insights from economics to explain the development of aquaculture production over time, especially focus on Norwegian salmon farming. But I really would like to continue this further in the aquaculture economics and management workshop to come, where we hope to extend this topic further and like go a bit more in depth. This workshop will be held in Ljubljana in September. It's aimed at PhD students and early career researchers. We want to have some economic grounding, but also work with practical, relevant research topics related to the participants. As lecturers, me and Frank Asche from University of Florida will be there, and we will structure the workshop in 3 days, moving from theory to practice. So the first day will be more like a bit more on this topics of economics, how this apply to aquaculture. And then we move to some hands-on data exercise. We will connect also in the second day with the research carried out during the conference. And then we will have also some interaction, industry interaction with the exhibitors in the conference, where we will hopefully be able to draw some further insights and connect everything, like all the theory and research to the practice. So to finalize, for this workshop, we will have some funding from the Norwegian Directorate for Higher Education and Skills, and it can cover some participation costs. And to apply, you should send me the CV, motivation letter, and some outlined expenses to be covered by May 30th. So here's my email, and yeah, thank you for the opportunity to have shared my thoughts, and I hope to see you in Ljubljana, where we can discuss further, or now with some questions. Thank you.
Thank you, Ruth, so much. This was really fascinating and very well-structured presentation. You walk us through the big picture of the economics, and thank you so much for sharing the concrete story of the Norwegian salmon aquaculture and how their productivity grew, the cost fell, and the industry transformed over the decades. Thank you as well for introducing us to the workshop. I feel that many of our today's participants will want to follow up on that. Now is the time to open the Q&A session, so we have 15 minutes. I would like to remind you to send any questions that you might have to the Q&A, so we can start with the discussion. I will open it up with the first question. Are there limits to how much aquaculture can keep growing? I think this is the question that many people are interested to know.
Yeah, I think in general, the question will be yes and no, because I think it all depends, right, on how. So growth, of course, and as I presented there, like there is many places that barely have aquaculture, right? So there is still a lot of space to grow and to expand. but first, yeah, of course we need to make sure that we are growing in a sustainable way, so that we are aware of the carrying capacity of the environment, right? But of course, as I said, like, all is related to technology, right? Like, we innovating and developing technology suitable for the growth of the expansion and in a sustainable way. So that is a yes or no question. Like, it all depends on how we develop the right technologies to grow.
Thank you. The second question I have is kind of related to that. What are the main environmental trade-offs of increasing productivity?
Yeah. So I think, and it's quite related to that, right? That I just said, because I think in one way, like, if you just increase the amount of fish there and like higher density, but you don't really count for other, like, or like the surroundings or exactly the carrying capacity of the environment and so on, then you have basically a trade-off, right, with the environment, and you were just putting more pressure on it. But actually, if you have the right technology and to actually, if you consider the surroundings, there is no trade-off, right? So it's not a it's you actually, by intensifying, sometimes you can actually even have a better, more efficient way, and you will, in a way, like, use less resources, right? So you will have a win-win situation where you are not wasting environmental resources. You were actually using them more efficiently by intensifying production. So it really depends on, again, like, how you use this technology, or how you are intensifying your production, right?
Mm-hmm. And why have costs started increasing again recently if technology keeps improving?
Yeah, so it's a bit. I think it's just a matter of also, like, yeah, as I said, I didn't have the time to expand a bit on that, but basically, all this improvement in technology, right? We mentioned, is a lot related to the farmers' technology, and a lot of the increase in costs are related to external factors that the farmers don't have control. So, for instance, the feed that I mentioned, it's something that it's given by the market, right? Like, how much, like, the farmer cannot control how much he will pay for fish meal or fish oil. But of course, there has been a lot of actually innovations on alternative feed ingredients that they are trying to come up with, and actually, over time, right, there has been, especially like feed ingredients, there has been a huge change from like a lot of fish meal, so has been reduced a lot to the use towards more soybean meal. So, but of course, all given, like, the demand, right, it hasn't is still catching up, right? The technology, it in, like, this feed ingredients alternatives, and basically the supply of it is lower than the demand, so the prices are still increasing, or at least not decreasing, right? How we expected. But the technology is there to catch up, and it has happened some innovations, but we're still not enough, in a way.
And And do you think that we should allow more growth, or we should be more restrictive?
Yeah, yeah. I think it. I think it really depends the context, right? It shouldn't. I think we shouldn't just grow in like indiscriminately, right? Like it not. It should be something that we actually account for how we are growing, right? It's not only about growth, it's about how we grow. So I think good regulations and making sure that we grow in a sustainable way is quite important. So I think that the need for it is there. Like we definitely need to have seafood as a source of protein, but we cannot just like let's grow, right? It should be consciously a choice, a sustainable way of doing it. So, and this is not necessarily easy, but I think at least should be the goal.
Mm-hmm. And now when we mentioned the aquaculture growth, it was not being uniform globally. So what do you think are the main barriers for countries or regions that have not yet seen the same expansion?
Sorry, can you say it again?
Yes. So regarding the aquaculture growth, what do you think are the main barriers for countries or regions that have not yet seen the same expansion?
Yeah, I know, for instance, that in US, right, they have quite restrict regulation on growing aquaculture. So I think in one way maybe they are being too restrictive in this respect. But ultimately it's about what they or as a society want, right? Like so it might be unevenly. I don't know if necessarily we should have evenly distributed growth, right? And everywhere. Not necessarily this should be a goal, but yeah, I think basically that is I think in general would be regulations that they should look for, like in a way that you wanted to provide the right incentives for the companies that have interest in growing to grow in a sustainable way, but not to like put regulations that just limits just for the limit, right? Like not should in a way should be good regulations that will allow those that are best suited for being there to actually grow, right? Like given their resources. Yeah.
Thank you, Ruth. We received a question from Mihai Vintila. That's actually the comment. I didn't see in your chart now how subsidized influence production.
Yeah. I mean, it's subsidies usually, right? Like will provide an incentive to produce more than not necessarily like it would be produced without with that subsidy. I know that like usually like they try, for instance, to provide subsidies to technologies that they actually think are more sustainable, right? So I don't have any of this information here, at least for the Norwegian industry. So I don't have much to say about it. But usually, right, you would provide subsidies to the technologies that you think are the best ones to go further.
Thank you, Ruth. I would like to remind you all that this is the final reminder for the questions you might have for Ruth. Ruth as well shared here her email address, so if you are feeling a little bit shy to ask publicly the question, you can always email her and she will be really happy to send you the answers. I have another question for you, Ruth. So you talk a lot about innovations. Can these innovations in Norway be easily applied to other countries or species?
Yeah, I think in a way, yes. I know that some of the, actually we always say, like, right, some spillover technologies to other species or other countries. But of course, like, it's really important to actually see the context, right? You're not necessarily what works for a net cage, even though tilapia and salmon are net cages, they not necessarily are completely transferable, right? Like, what it works in one doesn't necessarily works for the other. So in this sense, there are some points that are quite able to be passed on, to be transferred. Much of the knowledge, it is there has been some evidence about it that has been spillovers. But of course, the context really matter, and you need to adapt at least the technology to the right context.
Thank you, Ruth. I think with this question, we came to the end of today's webinar. I would like to thank you for the great presentation that you gave to us. It was an amazing to understand better the economic side of the aquaculture. And it was the great introduction for the aquaculture workshop that will take place during the Aquaculture Europe 2026 in Ljubljana. I would like to to remind you that the deadline for the application is May 30th. So please share this information about the workshop with your colleagues, with the students, because we want to see as much as possible applications for this. Ruth, if you have anything to say, feel free.
Just that, so the May 30th is application for funding, right? Like you can apply later if you have your own funding, right? Yeah.
Yes. And then, if you don't have funding, this is even better to attend the Aquaculture Europe and to gain the perspective of what's actually going on in the aquaculture world in the last 1 year. So it's a great way to network and to broaden your knowledge about this field. So as a last reminder, this webinar was recorded and I will send you the video by the end of this week. Thank you once again for being with us today, and we hope to see you at our upcoming EAStalk webinars and Aquaculture Europe 2026 in Ljubljana. Ruth, once again, thank you very much.
Thank you. See you soon.
Hopefully. See you. Yes.
Bye-bye.
Bye.